Good morning.
Good morning. How's everybody doing?
Good. How are you?
All right. All right, let's get started. Let's look at this exam number 10. All right. Uh, I just graded y'all's exams, and about half of y'all got both of these wrong, which is disappointing because this one right here, number one, was number two on the last exam, meaning I just worked that same problem in class. All right. A lot of y'all are solving for x here. What we want to do is we want to put it into y equals mx plus b form. That's slope intercept form. Okay. All right. So you're solving for y, not x. So y here is a function of x. M is your slope. B is your intercept. That's why it's called slope intercept form. Okay. So over here, if we're going to solve for y, we'll subtract x from both sides. Now divide everything by a -4. All right, that's slope intercept form. Okay. So the number that's multiplied by the x, that's your m. That is your slope. The number that's being added to your mx, that's your b. That's your, sorry, that shouldn't be a 12. Oh yeah, it should be. That's your y-intercept. So let's see here. If I let each one of these tick marks represent, let's say 4, put that right there. I label the point. This is 0, 12. So this is 4, 8. Oh no. No wonder it's wrong. Hold on. Let's try this again. I could divide everything by 4 here. So 12 divided by 4 by -4. 12 divided by -4 is a -3. So B is -3. So this is the y-intercept. So this point right here, 0, -3 is a point on the graph. Notice I labeled the point. Okay. Now let's get a second point. It takes 2 points to make a line. Since the slope is 1/4, if I go up 1 and go to the right 4, I get a second point on the line. And then I draw the line and I label this second point. So if I went up 1, I'm at -2. If I went to the right 4, I'd be at 4. Okay, so notice I've labeled 2 points and I've drawn the line through the points. All right, some of y'all just put 2 points. It says graph the following line. That means there should be a line there. Okay, so this is your slope intercept form. All right, y equals mx plus b. All right, don't give me x equals some stuff and then giving me m's that have y's in it and b's with x's in it and stuff. No, these are just numbers. There's no variables here. Tell me what the slope is, what the y-intercept is. All right. Again, at least half of y'all copied off of somebody that did it wrong. So y'all are going to have to get this down because the final exam is eventually going to get here and it's a significant part of your grade. Okay, I'm moving slow, a lot slower than the rest of the classes. Okay, so that y'all can keep up. So make sure y'all study, get this stuff down. All right, on number 2 here, it's the same thing. We have to get y equals mx plus b form. So if I add a half, if I add a half an x to both sides, I end up with this. I'm missing my y. There. Added a half x to both sides. Now I'll multiply everything by 4. So 4 over 2 is a 2x 3/4 times 4 is just a 3. So the m here, the slope is 2. It's the number that's multiplied by the x. And the b here is 3. The number that's added to your mx. And about half of y'all got this right or really close to right. You might have forgot one little thing or made one tiny mistake. But yeah, about half of y'all just totally did both of them completely wrong. We've done like 50 of these problems already. All right, B is 3. Make this line a little longer. Since B is 3, we go up 1, 2, 3. That's a point on our graph. 0, 3. Since m is 2, that's our slope. Let's see. We can either go up 2 and to the right 1. Or I can go down 2 and to the left 1. If I go down 2 and to the left 1, I'm right here. So I could either put a point up here or down there. Either way it works. So this point here, if I went down 2, I'm at 1, and if I went to the left 1, I'm at -1. So there's 2 points on my line. I label my axes. Okay. So get it into this form, slope-intercept form. This is where we're using the method. Tell me what the slope and the intercept are. That's part of this slope-intercept method. And then graph the line. So we graph the line. It takes 2 points to define a line. So I have 2 points here. They're both labeled, and there's a line through them. So that's everything that you need to do for these types of problems, okay? All right, let's check out the quiz here. All right, here's your graph. All right. All you're doing here is you're looking at the points and you're figuring out which is the x and which is the y. This one here, -2 is the x. What's the corresponding y value? Over here, they're giving you the y value, asking you what the corresponding x value is. All right, this should be really, really easy. It's either you get it or you don't. So take this time to collaborate with your classmates that understand this and take time to explain it to one another till y'all understand this, because this is very basic stuff. Because if you get it, it's easy. If you don't, it's impossible. Okay. All right, I'll put y'all into y'all's groups. It'll take 15 minutes. So we'll come back at 10:55. We'll take another minute. Sorry about that. I forgot your breakout rooms. All right, Sean. You know, somebody could have told me I forgot to put y'all in the breakout rooms. You know what I mean?
I thought it was on purpose, but
Huh?
I thought you did that on purpose.
No, I just gave you a long speech about how y'all need to talk to one another in your breakout rooms. All right. All right, let's check out the quiz here. So, I mean, there's like 5 points, 4 points labeled on this graph, right? Well, they're not labeled, they're just filled in. So all they're looking at here is the points. F of -2, right? All it's saying is x is -2. What's y? So at -2 here, what is that point? That point is this. Oh hell, this is -2, 0, right? All right, this is x. This is your f of x, which is the same thing as y. So f of -2 is going to be 0 because this is a point on our graph, right? Every single point is like this, f of x. You got the x and then the y. F of x is the same thing as y. So f of 1 here, be this point. This is 1, not that point, sorry. Be right here. That point is 1, that's the x value. What's the y value? It's like at negative 1.5 here. All right, so this would be a negative 1.5. F of 4, we go over here. Here's 4. So right there, this is 4, comma, let's see, where are we at? We're at 6. So f of 4 would be equal to 6. F of 0, all right, here's 0. We go down. This is 0, negative 6. So it'd be negative 6. So all of these, they gave us x. Just figure out what y is by looking at the graph. All of these, they're giving us y. And we need to find the corresponding x. So here they say y is negative 3. So if I go down 3, there's 2 points here, right? One of them is, well, they both have a y value of negative 3. See the first one, the x values, I don't know, like maybe a negative 1.8. See that? And then this one over here, I don't know, it's about what? It's a little past the middle, so it's like 0.6, you know? So over here, they're asking x is a negative 1.8 or a positive 0.6. It's both of those. There's 2 points that have a y value of negative 3. So on number 6 here, they're saying the y value is 1. So if I go up 1, there's 2 points here. See, this one is y value is 1. The x value is basically negative 2. So we have there's one of them, and then this one over here. No, it's not that, is it? Hold on.
So if there's 2 answers, basically we just put both of them. We don't like guess which one.
No, you just put both of them. So yeah, because when y is 1, right? There's 2 x values that'll give you a 1 back, right? Your left and right is the input, the up and down is the output. Well, if you plug you can put a negative 2 into f, and you're going to get a 1, or you can put in, what is this? Is about a 3.5. And you'll also get a 1, okay?
Okay, thank you.
Am I doing this backwards? Hold on. Yeah, because the function's going backwards. For one input, you only get 1 output, but going the other way, you can have 2 numbers go back to 1, like in this case, okay? 2 different x values happen to give you the same y value, okay? So if we look at negative 9, we go all the way down to negative 9. That point there has a y value of negative 9. The x value looks like it's negative 1. Okay. And for the last one, where f of x equals 0, when y is 0, we have 3 points here. This one, and this one. X could be negative 2, it could be a positive 2, or it could be a 3. All right, because if you plug any of those into our function, we're going to get back 0. Does that make sense? Inputs and outputs.
Yes.
All right. So I looked at y'all's exams some more, and I think I know what y'all are mixing up. There's the intercept method. Actually, it's intercepts method versus slope intercept method. Okay. So let's look at an example. What if I have 1x plus 2y equals 3? Okay, this is going to be our function, our equation. The intercepts method is where you find both intercepts. So if the graph looks like this, you're finding these 2 points, the points where they intercept your x and y axis. Okay. So to do that, we'd say first, let x equal 0. Then if we did that, we would have 2y equals 3 or y equals 3/2. So 0, 3/2 is the y intercept. All right, so that gives you the y intercept. Then you'd find the x intercept by letting y equal 0. If y is 0, we have x equals 3. So 3, 0 is the x intercept. And then you graph those 2 intercepts. So 0, put this 3/2. 0, 3/2, and then 1, 2, 3. This is 0, 3/2. This point is 3, 0. You got 2 points. They happen to both be your x intercept and your y intercept. That's the intercept method. You find the 2 intercepts. You let the x be 0, find out what y is. And you let the y be 0, find out what x is. That's the intercepts method. The slope intercept method, we have to put it into slope intercept form. So we would have this, and then y equals -1/2 x plus 3/2. So that's slope intercept form. Looking at that, we can say m is a -1/2 and b is 3/2. B equals 3/2. That means 0, 3/2 is our y intercept. So I'd be like, okay, here's 3/2. That's 1 point on the graph. Then I'd use the slope to find another point. If I go down 1 and to the right 2, down 1, and the right 2. So this point, if I went down 1 from 3/2, I'd be at 1/2. If I went to the right 2 from 0, that puts me at 2. And then I draw my line. Okay. So they're different. They're both related. Both of them involve intercepts. Okay. This one's typically easier, more versatile. Okay. But again, intercepts method, you find your 2 intercepts, you have 2 points, that makes a line. Slope intercept method, put it into slope intercept form. Now you know your slope and 1 intercept, the y intercept. Plot your y intercept, use the slope to find the other points. Okay. And this one's more useful because knowing the slope is useful. You can use the slope to get as many points as you want. Over here, you just got 2 points. All right. If you wanted to find out any other points on this line, you have to solve them, individually. All right, any questions about the difference between these two? All right. So let's hide my hat. All right, let's move on. On page 88, we did 7 last time. I'm not going to do 8. That's boring. Let's do number 9. All right, a bacteria population doubles every minute. Explain why this population growth cannot be modeled using a linear equation. All right, well, let's see. If it doubles every minute, let's say y is we'll use p for population, t is time. So population at time 0 should be 0, right? Well, we'll start off with 1. We have to have something to double, all right? So let's say at time 0, we have a 1. So at time 1 minute, we double that. At 2 minutes, we double that. At 3 minutes, we double that. 4 minutes, we double that, and so on, right? What would a graph like this look like? So at time 0, we're up here at 1. Actually, do this. No, let's move. Yeah. At time 0, we're at 1. At time 1, we're at 2. 2, we go up to 4. 3, we go up to 8. And then at 4, we're all the way off the charts. So this thing looks like this. It curves straight upwards, right? It's not a straight line. So that's why it can't be linear. Well, let me use t here. Time. What we're looking at here is an exponential function. It doubles every time, right? This is twice p of 1, right? This is twice p of 2. Right? It's twice the previous. Yeah. Hold on. This is twice the previous one. P of 1 is twice p of 0. P of 2 is twice p of 1. But p of 1 is twice p of 0. Right? P of 0 is 1. Right? So this is 2 times 2 times 1. So p of 3, it's twice the previous. But the previous p of 2 is 2 times 2 times 1. It's twice the previous, twice, so and so on. So this is 2 times 2 times 1. Right? This is 2 squared. This is 2 cubed. P of 4 would be twice P of 3. But P of 3 is 2 cubed. So we have 2 times 2 cubed, which is 2 to the 4th. This is an exponential function. Which is not linear. It's not a straight line. Let's get number 10 here. How much water should be added to 1 quart of 3% milk to result in a 2% solution? How many quarts of 2% solution would this make? Well, it looks like they're throwing a mixture problem in here out of nowhere. All right, so remember our V1 C1 plus V2 C2 equals V3 C3. All right, so let's see. How much water should be added? So water would have a concentration of 0. All right. So it looks like how much water, looks like we don't know what V1 is, but its concentration is 0% milk. And it looks like 1 quart of 3% milk. It looks like our V2 here is 1 quart and its concentration is 3%. And we're resulting in a 2% solution. So we don't know what V3 is, but we know its concentration is 2%. So they want to know how much water to be added. So that's the V1. And how many quarts of the 2% solution. So they're asking what is V1 and what is V3. Okay. So they're giving us, there's 6 variables here, right? V1, C1, V2, C2, V3, C3. But we have 2 unknowns. But we can solve them because we have 2 equations, right? We have V1, C1 plus V2, C2 equals V3, C3. We also have V1 plus V2 equals V3. 2 equations with 2 unknowns, we can solve them, okay? So V1, this equation, we're missing 2 out of 3 of them, right? We don't know what this is. We don't know what this is. So it's kind of hard to solve that. But this guy up here, let's see what we can do. Let's plug in some numbers here. We don't know V1, but we do know C1, right? V2 is 1 times 3%. We don't know V3, but it's at 2%. Okay, just looking at that, they made it really easy for us because they made this one 0. Whatever V1 is, V1 times 0 is just 0. So look at that. That thing there lets us solve for V3. Once we know what V3 is, we can plug it in down here and solve for V1. So this guy here tells us that V3 is 2%. Hold on, 3%. All right, this is just 1 times 3% is just 3%. We're dividing both sides by 2%. So it's 3 halves. V3 is 3 halves. All right, so that's how many quarts of 2% solution we're going to end up with. Okay. Now, since we know V3 and we know what V2 is, we can plug them into this one. We don't know V1. V2 is 1. V3 is 3 halves. Subtract 1 from both sides and get 3 halves. So 3 halves minus 1 would be 1 half. All right. So this is a tricky problem. It's a mixture problem. Again, there's 6 variables. They're giving us 4 of them. We have to solve for the other 2. Okay. Excuse me.
Bless you.
Bless you.
Thank you. So the hard part is just identifying your variables, right? But it can't be that bad. There's a quantity of water, and there's a quantity of 3% milk, and there's a quantity of 2% milk. So those are your V1s, V2s, and V3s. All right, and then you just got to figure out the concentrations. They tell you the concentration of this one. They're asking you about they're asking you about the volume for that one. They give you the concentration. And this one, being water, they're giving you the concentration, but asking you about the quantity. All right, got my homework. All right, page 91. Let's see what they have for us here. Good old scam likely. Explain in your own words the relationship between ratio, decimal, and percent. Okay, give an example of each. You may find it more helpful to answer part B before part A. And then we'll look at part C. Ratio, decimal, and percent. Well, let's look at like 2/3, right? 2/3 is a ratio. As a decimal, it's 0.66. All right, with the line over it, 0.666666. As a percent, this is 66.6 over 100. So this is 66.6%. All right, so there's the ratio, there's the decimal, and there's the percentage. All right, so which of the following can be written as a percent? Traveling 55 miles an hour. That doesn't make any sense as a percent, right? A percent works if the units on the top are the same as the units on the bottom. Miles per hour. Miles and hours aren't the same thing. No. Okay. 21 students pass a math test out of a class of 24 students. So we're comparing students to students. 21 out of 24. Right? That gives us a whole number. This one we can write as a percentage. 195 calories in a donut. We're comparing calories to donuts. That can't be written as a percentage. Earning 2 hours and 24 minutes towards your exam 1 lab requirement, which is 200 minutes. Here we can do a percentage because we're comparing minutes to minutes. Okay. Does that make sense? Kind of sounds odd. You earn so many minutes towards a lab requirement. But if the requirement is also in minutes, then you are comparing minutes to minutes. Okay, I see. We're doing review. That's why they're throwing mixture problems in there. Find all the errors and explain how to fix them. Lewis left a $5 tip on a $22.70 check. Then the percent tip he left is, well, let's see. He left a $5 tip on a $2.70 check. Yeah, that's not right. We would want to have 5 out of 22.70, right? They just did it upside down. If we did that, my calculator. 5 divided by 22.7. This is 0.22 approximately, which is 22%, not 4.54%. All right, what is a proportion? How can you recognize when a problem can be set up as a proportion? Make up a proportion problem. All right, a proportion is when you have something like this. Okay. You're comparing like ratios. All right, so let's see. Let's see, let's make up a proportion problem. 3 out of 5 students passed today. So if we have the same passing rate, how many out of 50 will pass tomorrow? Okay, so if we have 3 out of 5, 3 passed out of 5 total, how many will pass out of 50 tomorrow? And then you solve for X.
I'm so sorry, sir. With that last problem, how did you set up the proportion? 3 over. Okay, thank you so much.
Yeah. 3 out of 5 is our ratio. We're using that ratio and we're comparing it to this question. So when I say how many, it's basically X out of 50 will pass tomorrow.
Okay, thank you so much.
Sure. Number 4, in 2018, only 551,073 people voted out of over 1 million registered voters in Bexar County. If 1.3 million are registered in Bexar County, predict how many of them will vote. All right, we can do this with proportions, right? 551,073 out of 1,073,320. That's the ratio of people that vote. Comparing that to how many out of this many. All right, so multiply both sides by 1.3 million. And let's see what we get. 551,007, dang it. 551,073 times 130,000 divided by 1,073,320. I'm getting 667,456.95. So I'm gonna round that up to that. You doing it as second method, we could do it with percentages, right? We could be like, oh, this many, that's the percentage, right? 551,073 divided by 1,073,320. That's 0.513 or 51.3% vote, right? Well, if that percent votes, then we take, okay, so here's our 1.3 million. And I could be like, take 51.3%, right? But that's an approximation here, right? So instead of putting that, I'm gonna put this, because it's the same thing as our 51.3%. But it's more accurate. And notice this number is exactly the same as this number. We're doing exactly the same math. All we're doing is interpreting it differently in our head. All right. So again, this is our percentage here. But instead of putting 51.3%, because that is an approximation to this, I'm just using the same fraction here. All right, name 3 units that are part of the metric system. three that are not. Let's see, we got meters, grams, liters. Those are the basic three. 3 units that are not, we got what? Inches, what do we use? Ounces. So that's a length, that's a weight, or weight, and pounds. So that's a length, mass, no, length of volume and a weight. Describe 2 ways you can perform conversions within the metric system and give an example using each. One was using that chart, right? We know that 1 kilometer is 10 to the third meters, right? So if I have 17 kilometers and I want to convert that to meters, I just replace kilometer here with 10 to the third meters. So I can do it via substitution, or I could be like multiply it by a smart one. Get rid of kilometers in favor of meters. 1 kilometer is 10 to the third meters. Kilometers go away. All right, so those are 2 ways you can do your conversion. Substitution, right? Just substituted that out, boom. Or using a smart one. All right, explain the difference between converting 100 feet to centimeters versus 100 feet squared. This one you have to do it twice, right? There's 2 conversions. 100 feet versus 100 feet squared. This one, we get rid of feet for inches. 12 inches make a foot. This one, we got to get rid of feet twice. 12 inches make a foot, 12 inches make a foot. All right, this is 1200 inches. Whereas this one here, 1200 times 12. This is 14,400 inches squared. Inches squared. So they're not the same, right? There's an extra factor of 12 in there. All right, let's see. It's 11:30. Let's take a 15-minute break and we will continue on. All right. So come back at 11:45. All right, class. Let's keep going here. Page 92. All right, 2 different methods for graphing a line. I showed y'all earlier, you have the intercept method and the slope. Oops. Intercept method. All right, 2 different methods. The first one, you find both the intercepts, label those points, draw a line through them. Slope intercept, you put it into this form. Then you know your slope and your y-intercept. All right. When y'all graph, make sure you label your points on your graph, please. I keep telling y'all and telling y'all. Eventually you'll get it. I haven't taken many points off for that, but in the future I will. Because when you do this, and if you only label 1 point, I can't tell that you understand your slope to find the other point. Okay, so you have to label your points so that I know that you get the concepts. Look up, puppy dog. I'll pet you later. Go on, get, go on. Go. Later. All right. All right. So how are they similar? How are they different? They both involve finding your y-intercept. All right. That's why they both have the word intercept in them. But the intercepts method, you're finding the x-intercept and the y-intercept. Okay. They're different. And then this one, you explicitly know your slope. Which one do I prefer? I prefer the slope intercept method. Because once you put it like this, you also have it in function form. Because f of x is the same as y. You can think of it as a function instead of just this relation between two variables. Okay. Oh, and by the way, like, I know math is hard, but it's really not. Because if you think about it, your other classes, they give you like hundreds of pages to read. I mean, we cover like 4 or 5 pages in a day. You know what I mean? If you spent the same time it took to read 100 pages to think about these 4 pages, you'd see that math is a lot easier than your other classes. It's a lot less work anyways. It's just a different type of work, you know? You just have to sit and think about a little bit of stuff until you get it, you know? I like that way better than reading and reading and reading and reading. I hate reading. I don't know how y'all feel about it, but I hate reading. If you think about it, there's only what 26 different characters in the language, and there's only one color, black ink, you know? So it's just 26 characters, and then they have to take all their ideas, no matter how abstract and so on, and they have to encode it into 26 letters. That's just boring. Textbooks should come on like textbooks on tape or whatever, audio textbooks where they just read it to you while you drive or clean your house. I used to scan my textbooks and then do the OCR to convert it to text and then have my computer read it to me. All right, the equation 4x plus 2y equals 8 is equivalent to this equation, y equals negative 2x plus 4. What do they mean that they are equivalent? It means they're saying exactly the same thing in 2 different ways. Okay, it means if you graph them, you get the same graph. They have the exact same set of solutions. Okay. All right, what information can you obtain from each equation to draw its graph? Well, if we could put this into this form, right? Subtract 4x from both sides, divide by 2. Right? They're the same thing. They're going to have the same graph. So let's just use this since it's already over here in slope intercept form. We can see our m is negative 2 and our b is 4. 1, 2, 3, 4, boom, 0, 4. Look, I'm labeling the point. The slope is negative 2, so I go down 2 to the right 1. This is 2, 1. Oops. Okay, if I just label this point, if I didn't have this here, how do I know what this point is? All right, whenever you label this point and you write these numbers here, that's how I know that you understand this concept and used it to figure this out. Okay, so label your points.
I have a question. It's kind of dumb though.
No, there are no dumb questions.
So since it's only like a negative 2, and like not a fraction, why do you go to the right one? Is it because it's negative?
It is a fraction, see?
Oh, okay.
All right, makes sense now, right?
Yes, it does.
All right, cool. Yeah, that's a good question. All right, I could also write it like this. So instead of going down 2 into the right 1, I could have gone up 2 into the left 1. Right? That point up there, if I went up 2, I'd be at 6, -1, 6. All right. Either one of those points would work.
Okay, sounds good. Thank you.
Sure. Let's see here. Find the slope of the line by counting the rise over the run between points A and B. Well, if I go down 2 into the right 1, down 2 into the right 1, the slope is -2. All right, slope's negative. We're going downwards from left to right. If you're going downwards, you know it's negative. Down 2, right 1. Find the slope of the line using the XY coordinates of A and C. Okay, well, we're doing the same thing. We're just going to write out a bunch of numbers. Point A here is -2, 1, 2, 3, 4, 5. Point C here is 2, -3, right? We could do the same thing. We could be like, what's the distance there? There's 5 and then another 3. That's 8. We're going down 8. And we're going to the right. 1, 2, 3. Going to the right 3. -8/3. All right. What they want us to do though is just go like this. M equals the difference in the y's over the difference in the x's. So here's the first one. Our y, we have 5 minus a -3. And then the x's, we have -2 minus 2. So 5 minus -3 is 8 on the bottom. Oh, what the hell did I do? I'm getting a -2. I counted wrong over here. Should be the same thing. I should have -2. So 3, yeah, that's 8. Okay, from here to here is 4. Okay, this is the math, just writing it out using the equation. But all this math is the same thing as going, okay, from here to here, that's 8. And from here to here, that's 4. 8/4. And it's down, so it's negative. Does that make sense? See, if it's hard to eyeball, right? If they didn't have these tick marks, what if they didn't have these tick marks, the grid there? They didn't have the grid and they only had these numbers. You kind of have to do it this way, right? You wouldn't just be able to count them. You'll follow why we use the equation here? Why we need to sometimes? Right? Why is it the same? Why is it whenever I look at these 2 points, I get a slope of -2? If I look at these 2 points, I still get a slope of -2. Because the line has the slope of -2 no matter which 2 points you pick. I could pick this one and this one. All right. I'm going down 4 and going to the right 2, slope of -2. All right. Let f of x equal -5x plus 20. Describe the difference between f of 0 and where f of x equals 0. All right, this one they're saying x is 0. X is 0. What's y? This one they're saying y is 0. What is x? Right? F of x is y. Does that make sense? F of 0, take x and replace it by 0. We get 20. Now over here, they're saying f of x let it be 0, but f of x is negative 5x plus 20. We're just replacing f of x with 0, and then we're solving. So we have negative 20 is a negative 5x. So x is 4. Okay. So f of 0 being 20, that means 20, 0 is a point. No, I did it backwards. 0, 20 is a point on the graph, right? X is 0, so y is 20. Here they're saying for 0 is a point on the graph. They say let y be 0, find out the x. Okay. It's not complicated. One's the input, one's the output. One's x, one's y. This is your relationship between x and y. Okay. All right, page 93. That's our review. All right, we're prepping for quadratic functions. Quadratic functions are just ones where you have squares in them, x squareds and y squareds. Well, just the x actually. Match each mathematical notation to a correct definition. Let's see. Let's look at the definitions. A point that is 1 to the right of the origin. Well, that's this one. 0, 1. That's a point that is 1 above the origin. Oh, hell. I did it wrong. A point that is to the right of the origin. That's this one. All right. The 1 here is to the right. 1 above the origin. That's this guy, 0, 1. Right? The y value is 1. A vertical line. All right. X equals 1. This works. That's a vertical line. If I look at all the points where x equals 1, it would look like a vertical line. Okay. A horizontal line, that would look like this. Y equals 1. All right, a horizontal line. Right there, there's 1. Every single point on this line has a y value equal to 1. All right, let's go back to D. A possible solution to an equation with variable x. X equals 1. And the very first natural number, 1. Our natural numbers is a set of numbers. And it depends on who you ask. Some people started at 0, but these are your natural numbers. It's a set. I use a funky N to denote that set. You have natural numbers. You have rational numbers. All right. The rationals look like the set of all A over B. Actually, between there, we have natural numbers. Then we have the integers. All that is the naturals and the negative naturals. So -2, -1, 0, 1, 2, 3. So they denote the integers with a funky Z. And all it is the naturals, but with their negatives and throw in 0. The rationals are all A and B such that A and B are elements of the set of integers. So stuff that looks like 2/3, 1/5, -2 over -2. That's the same thing as 1, right? 3, because that's 3 over 1. Take one of these and put it over one of those, and you have the rational numbers. And then you also have the real numbers. All right. That has all the rationals and plus the irrationals. All right. Rationals, fractions. All right. Fractions can be written as their decimal repeats. Okay. rational numbers, they can be represented as a fraction. That means if you convert it to a decimal, it's eventually going to repeat. You know, like 2/3 is 0.6666, right? Well, you might have like 1,073 over 4,521. And then it might have, if in decimal form, it might have 3,000 digits before it starts repeating again. But rational numbers are going to repeat. The irrationals are the decimals that never, ever, ever repeat. What that means is you can't write it in a fraction as a whole number over a whole number. If you put the rationals and the irrationals together, you get all the decimal numbers. Decimals. Okay. And eventually we'll get to imaginary and complex numbers too. Because y'all thought all your numbers fit on a line, right? The number line. Here's all your real numbers, 0, 1, and then you got an infinite number of numbers between 0 and 1, and so on. It turns out you actually have a number plane, a complex number plane, where you have imaginary numbers. And the imaginary numbers are just as real as the real numbers. It's just that the term real number had already been taken. So, oh, and the reason why these are called irrationals is because math used to be a religion, and Pythagoras said all is number, and for him all numbers were represented by fractions, a whole number over a whole number. So their religion, you couldn't have a number that wasn't a whole number over a whole number. Turns out square root of 2, that's an irrational number. It can't be written as a decimal that doesn't repeat. That a decimal that repeats, it can't be written as a whole number over a whole number. So if you thought irrational numbers were existed, well, you were an irrational person. And in fact, the first person that proved to Pythagoras that irrational numbers existed was taken out of boat and killed. He was the first mathematical martyr, because if you prove somebody's religion is wrong, they don't like it. So notation, notice notation, notation, notation. That's why you label things. You got to get your notation down. All right. You got to be organized, because when it comes to math, the concepts eventually get so complex that it's the notation that keeps it all together. You can work the problem if you do the notation correctly, because just working it out on in your head doesn't fly anymore. The notation is your tools, right? We only need the number 1, right? We don't need 2. All we need is 1 plus 1, right? 2 is a simple concept, right? But if all you knew about was 1 plus 1, you don't need number 2. You don't even need 3, 4, 5. But if you have an 8, if you don't know about number 8 and you're only thinking this, 1, 2, 3, 4, 5, 6, 7. If this is what your mind has to use to understand the concept of 8, well, suddenly the concept of 8 becomes so complex that it's really hard to even think about. And this is where mankind was for a long time. There's still cultures out there that the only numbers they have are 1, 2, and many. They don't even have numbers. And the way they do stuff is by tokens. So if some guy wants to send somebody to get him 50 sheep, he has to count out one by one 50 tokens, basically pebbles. He'd just get a handful of pebbles and tell him, this is how many sheep I want. And the guy would show up, give the guy 1 pebble. That guy would give him 1 sheep. He'd give him another pebble. He'd give him another sheep, because they don't have any concept of number itself. So the number 8 is a notation that makes the idea of 1 plus 1 plus 1 plus 1 simple enough to wrap your mind around. Does this make sense?
Yes, it does.
All right. And multiplication is just repetitive addition. Exponents is repetitive multiplication. So master your notation. All right. All right. This guy here, this is a line. So they don't put this. They should use their notation and label their x-axis and their y-axis. So that's a line. That line there is y equals 3. Over here, x-axis, y-axis, they mean that's a line there. This line is x equals 3. Notice every single point on that line has an x value of 3. This right here, this is a point. This is a -3, 0. So line, point. All right. Oh boy, the vertex formula. All right, the vertex formula. The following expression will be used to help find the vertex of a quadratic function. -b over 2a. So they give us an a and a b. We plug them in. We plug in a 6 for b and a 3 for a. And we get -1. Okay. Not so hard so far, right? Just remember -b over 2a. The reason why we need this is because what we're going to look at is things that look like this. ax squared plus bx plus c. All right. And if we have this equal to 0, and we're trying to solve for x, notice there's an x to the first power. We just don't write it. And an x to the second power. So all we're going to do is extend our skills to deal with when you have squareds. Eventually go to cubes to the 4th, to the 5th, and then to the nth power, and then you let n go to infinity, and you're in calculus, okay? So that's how you progress through math. First power, now we're going to second power. So, and this is all the possible quadratics. So we're talking about stuff that looks like this. A, B, and C are your parameters, all right? Sorry. All right, they're the numbers that could be multiplied by your x squareds, your x's, and stand by themselves. So this would be your a, this would be your b, and it turns out a -b over 2a is going to be important. It's going to help you find the solutions. All right, there's going to be 2 solutions. Since you have a power of 2, there's going to be 2 solutions. A -b over 2a is something we're going to use a lot. Okay. Spot the error. Okay. Two students attempted to evaluate -8 over 2 times 4 using calculators. So I guess people are screwing things up with their calculators. You can look at this and know that's -1 just by looking at it, right? So student A does 8 divided by 2 times 4 and got -16. Obviously that's wrong. Okay. They shouldn't be multiplying by 4. Yeah, that's 2 times 4, but it's 8 divided by 4. They should have a division here. All right. Over here, they put in the parentheses. So if your calculator is one where you can put parentheses, then use them because you're dividing by this whole thing. You're dividing by 8. Okay. So be careful with your calculators. All right. If you're not sure, do a simple version like this. You know this should be -1, and then test out your method. All right, -b over 2a. All we're doing is we're replacing b with 8 and a with 1. So we get a -4. -b over 2a, we're replacing b with a -9, 2 with a -3. So we got 9 over 6, which is 3/2. -b over 2a, placing b, placing a. There's a minus over a minus, so we got a plus. 16 over 4 is 4. All right, these should be easy. Just be careful. All right, on page 95. Okay, for the function f of x equals -5/2x, find f of 3. F of 3, we're just replacing the x with a 3. F of -5, we're just replacing the x with a -5. So this is going to be a 1/2. All right, -5/2 times 1/4. So we have 5. 2 times a fourth is a half. Dividing by a half is the same as multiplying by its reciprocal. Okay. Let's look at this example here. Find f of 2 for this function. All right, we just replace the x with a 2. All right, so it's 3 times 2 squared minus 4 times 2 plus 7. All right, so you have to do the 2 squared first, okay? Otherwise, you're going to get the answer wrong. Exponents go first. They didn't have to put the parenthesis there. 3 times 2 squared. Do the exponent first, okay? We do our math, we end up with 11. All right, so 3 squared, 2 squared is 4. I guess they didn't do anything here. All right, they only did that one step. So 3 times 4 is 12. That's our -8. We still have the plus 7. So 12 minus 8 plus 7. 12 minus 8 is 4. 4 plus 7 is 11. All right, for the function g of x equals 4x squared plus 5x plus 6, find g of 3. I'm just replacing the x with a 3. 3 squared is 9. 5 times 3 is 15. 9 times 4 is 36. 15 and 6 is 21. So this is 57. Here I'm just replacing x with a -1. -1 squared is a +1. So 4 times 1 is just 4. And then 5 times a -1 is a -5. So 4 minus 11 is a -7. Here I'm just replacing the x with a 1/2. So 1/2 squared is a 1/4. Okay. So 4 times a 1/4 is just 1, right? And then 5 halves and then 6. 6 and 1 is 7. Let's get a common denominator. So I'll multiply the 7 by a 2/2. So I got 14 and 5, and they're both over 2. So 19 halves. Questions? There's more of the same. You give us an h of x, h of 2, replacing x with a 2. So 2 squared, I have a minus sign. Maybe I should do it like this so y'all can see a little better. 2 squared is 4. I have -14 minus 8. So 14 and 4 is 18. and 8 be negative 26. H of negative 1, I replace the x with a negative 1. So the negative 1 squared is a positive 1, but I still have this minus sign, right? So negative 7 times a negative 1 is a positive 7. So negative 9 plus 7 would be a negative 2. All right, if I replace x with with a negative 4, I get that. So I have a minus sign. The negative 4 squared is a positive 16. Negative 7 times a negative 4 is a positive 28. 28 minus 8 is 20, minus 16 is 4. All right, here's another function. Find f of negative 1. Replace x with a negative 1. At a minus, negative 1 squared is a positive 1. I still have this extra minus. Minus 4 minus 8. So it's what, a negative 13. F of 3/4. Place x with 3/4. So 3 squared is 9, 4 squared is 16. All right, now I need a common denominator, right? So I'll multiply the 3 by 16 over 6. Well, hold on, let's combine these. 3 minus 8 is negative 5. So let's get a common denominator now by multiplying by 16 over 16. What 16 times 5? 16 times 5, 80. I got a negative 89 over 16. All right, replace x with a negative 1/2. I got a negative 1/2 squared plus 4 times a negative 1/2 minus 8. This minus squared becomes a positive, but then I still have this extra minus. 1/2 squared is a 1/4. I don't even need parentheses here. Yeah. 4 over 2 is a 2. So let's see, I need a common denominator. So I'll multiply this by a 4 over 4. And negative 1/4 minus 40 over 4. Excuse me, a negative 41 over 4. So all we're doing is substituting here, or evaluating the function. What is an intercept? That's where your graph crosses either your x-intercept or your y-intercept. All right. This is a linear equation, right? It's a straight line. That means you have x is the power of 1. All right, your y-intercept is right here, 0, 2. The x-intercept is right here at negative 5, 0. This thing is a quadratic over here. That's why it's shaped the way it is. If you have something that's on the order of 2, it's going to look like that. If you have something that's on the order of 3, it's going to look like that. If you have something that's on the order of 4, it's going to look like that. All right, 1, 2, yeah. Every time you have an extra power of x, it puts an extra curve in your graph. Okay, so here our y-intercept is here, 0, -2. The x-intercept is at -2, 0. Okay. X squared looks like this. This is just like that, but it's kind of shifted to the left and down. So we'll start to see how to graph stuff by looking at it. Are the two expressions equivalent? Yeah, because they're equal, right? What about this one? This is 5 plus 6 over 3, which is 5 plus 2, which is 7. This is 11 over 3. That's not 7. So no, they're not. Okay. This would be 5 plus 6 divided by 3. What do the symbols infinity and negative infinity mean? Where are they located on a graph? Right here and right here. This is 0, right? So when might they be used? In calculus, or if you're talking about directions, or dividing by 0. So 98. All right, plot the following points, then connect them in order. -10, 0, -8, 1, -6, 2, -4, 3, 0, 5, 4, 3, 6, 2, 8, 1, 10, 0, 4, -3, 0, -5, -4, -3, -10, 0. So to connect them in the order that they were listed, looks like that. Let's do this again. Now they're going to throw in some decimals. Okay, no problem. -2.5, 0. -1.752. 1.752. 2.5, 0. 1 3/4, -2. -1 3/4, -2. -2.5, 0. Connecting them in order. All right. 1 3/4 is the same as 1.75. I think we have time to do these two. Graph the function f of x equals f by completing the table. All right, all you're doing is the input is the same as the output. So -3, down 3, -2, down 2, -1, down 1, 0, 0, over 1, up 1, over 2, up 2, over 3, up 3. This is your most basic function. F of x equals the x. The input is the same as the output. Notice this is the same as 1x plus 0. Your slope here is 1. Your b is 0. Boom. 0, 0. Slope is 1. Go over 1, up 1, over 1, up 1. Right? All your other lines, anything that was like a 2x plus 1 or anything else, they're all straight lines. Right? Anything linear is just a straight line. It's just this thing and moved up or down and twisted. Okay. Now this guy here, this is your most basic quadratic. Okay. X squared. All your quadratics look like this. This one is just A is 1, B and C are both 0. It's your most simple quadratic. All the other ones where you actually have A, B, and a C look exactly like X squared. They're just like, just move to the left or to the right, up or down, and then like either contracted or stretched. So some of them are like this, some of them are like that. Some are over here, some are over there. All right. But you'll be able to look at anything like this and know what it looks like by contorting the graph of x squared. So all we're doing is we're taking the input and squaring it. So a negative x squared is a 9, negative 2 squared is a 4, negative 1 squared is a 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. Notice these are the same numbers. All right, that means that the graph on this side is going to look exactly the same as the graph on the right side. Okay, so if we graph this, we go to negative 3, we got to go up to 9. Negative 2, we're going up to 4, a negative 1, we're going up to 1. And on the right hand side, 1 squared is 1, 2 squared is 4, 3 squared is 9. This is our graph of x squared. F of x equals x squared. X. Okay. All right, we'll leave off there. Let's see, we need an exam here. This is what, exam number 11. It's fine. Here's our homework section. Let's do this. Number 1. That's number 3 on page 89. Number 4. Some consistency here. All right, there's your 2 problems for your next exam. Get it in by midnight, and I will see y'all on Monday.
Have a good weekend, sir.
You too.